I would like to try to make this part entertaining, but I'm not really good at accents or funny voices or anything. But remember, pause symbol means you pause the slide, and then when you're ready to go on, unpause to go to the next part. Today's objective. The student will be able to divide whole numbers with remainders. This will be done through a presentation and classroom activity. This is just basically one extra step. What happens is before we had problems and they all had a little clear ending. It's always 0 as that last number when we subtract. But now what happens if it doesn't add up to be 0 and we don't have any numbers left? What we're going to do is we're actually going to have remainders, and we're going to go over that right now. So long division with remainders. As I just said a second ago, we're going to have remainders. So it's a leftover number after we're all done and over with the problem. So we have to find out how many times does 3 go into 2. So 3 doesn't go into 2 evenly because it's between the 2 and the 3 over there, so we always use the number right above it. So we're going to use the 1. So 2 times 1 is going to be 2. So we bring that 1 and we put it above the 3. So now we put that 2 that we just had. The 2 is going to go below the 3, so 3 minus 2 equals 1. Next we need to drop down the 3, so now we have 13. And we need to find out where 13 falls in. So 2 times 1 is 2, times 2 is 4, 3 is 6, 4 is 8, 4 is 8, 5 is 10, 6 is 12. Right over there, 13 lands between 12 and 14. So it lands between 12 and 14. I said we use the number on top. So we're going to use the 6 instead of the 7. So we put the 6 on top of the 3. So now we're going to put that 12 below the 13. So 13 minus 12 equals 1. So now we need to drop down another 3. So now we're going to have 13 again. So we already know this answer. From the last one, we found out that 2 times 6 equals 12. So if 2 times 6 equals 12, it's going to be the same number. So we're going to put that 6 back on top of the other 3. It's going to come there in a second. Sorry if the timing's a little bit off, you guys. And now that we have 12 again, because 6 times 2 equals 12, we put the 12 below the 13, we subtract it, it equals 1. So now last we drop down that 7, now we've got to find out where 17 lies. So again, 1 times 2 is 2, 2 times 2 is 4, times 3 is 6, times 4 is 8, times 5 is 12, and if we keep 5 is 10. If we keep going down, we're going to see 8. So, because it lands between 16 and 18, so we put that 8 up top. So now 8 times 2 is going to be 16. So now if we drop that 7 we drop down, 17 minus 16 is going to be 1. So now that 1 at the bottom, we've never had a 1 at the bottom like that before. We've always had a 0. So if we take that 1, we're going to move it up top behind the 8 and you write r equals 1, or the remainder to this problem is going to be 1. This time we're going to do 5 divided by 4. So 5 divided by 4, we have to find out it falls right between the 4 and the 8. And the reason we don't use the 8, if we minus 5 from 8, you're actually going to have a negative number. That's why we use the 4 to keep it in the positive. So we put that 1 on top of the 5. So now that we did that, 4 times 1 is going to be 4. So 5 minus 4 equals 1. So now we drop down the 4, so we take our little arrow, point our little arrow down, we put the 4, so we're going to have 14. So 4 times 1 is going to be 4, 4 times 2 is going to be 8, 4 times 3 is going to be 12, 4 times 4 is going to be 16. So that 14 lies between the 12 and the 16. So we're going to take that 3, and we're going to put that 3 above the 4. So now that we put that 3 above the 4, we do 4 times 3, which is going to equal 12. So we take that 12 and we put it below the 14. So 14 minus 12 is going to equal 2. Now that we have that number, we have to drop down the 3. So we have 23. So now we have to find out where 23 goes. So 4 times 1 is 4, times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20, times 6 is 24. So since 24 is too high, we actually have to use the 20, or the 5. So we'd put the 5 on top of the 3. So when we put the 5 on top of the 3, we take 4 times 5 4 times 5 will give us the 20 I was talking about earlier. So 23 minus 20 equals 3. So we drop down that last 3. This is the last 3 we're going to use for the day. And we have 33. So we're going to go down that line again, and we're going to have to find where does 33 fall in the line. So 33 is going to fall way down at the bottom between 4 times 8 and 4 times 9. So we're going to take the one above it, the 8. We put the 8 on top of the 3, the second 3. So now we have 4 times 8 is going to be 32. So we take that 32 and we put it down at the bottom. 33 minus 32 is going to equal 1. Now remember, we have a remainder now, so we need to do something with that remainder. So we take the 1, we bring it all the way up top, and we write r equals 1 for remainder equals 1. I know that there's no pause screen, because I thought you guys could pause right here and figure out, hey, I'm getting the concepts, I'm not getting the concepts, I can go back. Because all I'm giving you is 2, 4, 6, 8, 10 problems. Take 5 minutes, do 2 or 3 problems, 4 problems, see if you're getting them right. If you're getting them right, awesome, you understand the concept, you can go on. If you get them wrong, keep going down, and hopefully you can get them right as you go back and review the slides. So good luck on these next few problems. Okay, to recap, I'm going to keep it short and sweet. We went and redid long division, but this time we did long division with remainder. So just a little bit more to add on. There's a lot that goes on with the long division. Later you're going to find out we can do remainders, we can put them over fractions, we can do this, we can do that, repeating decimals, terminating decimal, all sorts of stuff. But right now we're just learning about long division with remainders. That's today's unit. To recap our objective, the student will be able to divide whole numbers with remainders. This will be done through a presentation and classroom activity. Enjoy your evening, guys.